Hello everyone, is the Prophet Michael David, aka Aries, and today's going to be another maths day. Alright, first things first, the thumbnail. That is a variation of what's called an Ulam Spiral, and this is the wiki for Ulam Spiral. Okay, one cool thing I found while I was making this video was for almost all of my videos I have some sort of thumbnail, um, that at least somewhat pertains to my videos and everything. And so as I was taking a screenshot of that Ulam Spiral, sometimes as it happens, my initial screenshot is too big for the attachment for the YouTube video. So I have to basically open it up and size it down a bit and then retake the screenshot. Well, as I did that with the Ulam Spiral, you could see like a pattern, almost like look into the picture long enough and you'll see a pattern, but you can see it come out of the page and go back in, almost like it didn't look like totally rhythmic and everything. And that could be part of the screenshot procedure. You're just seeing, a pattern in the screenshot, but I don't think so. I think it's an intrinsic pattern in the primes themselves. They always have had a very fractal nature to them. Like even the Riemann hypothesis, the zeros, if you guys are familiar with it, like the first one is 14.1347 something. The second one was 21.0220. Like to me, I've always believed that they're hard to model because they represent both very large numbers and very small numbers, but not numbers we normally deal with. For instance, like 14.1347, I think that's basically, those are the logarithms. So the real number is e to the 14.1347, which is like almost 1.4 million, and then they just go up astronomically from there. All right, this video is called Admorials 2. Yeah, I know it sounds kind of like a B-roll Marvel movie or whatever, but so even if you haven't watched my last video, which you should, I'll go over basically what it is and what I told you guys I was going to do with it and how I was really excited, but it didn't really turn out as well as I thought. So here we go. That is my Admorials spreadsheet. Again, Admorials, I just added up all of the prime numbers in order, and then I did an analysis to see which mod lines that they fell on, and then the sum on the right hand of the page that shows I just summed up that row and to find out which mod line that they were on. So then I also graphed them, and then I used the equation, approximation thing on the spreadsheet, and I was like, wow, I've never had an r squared equals 1 before. This is the best fit I've ever seen. So that's why I told you guys I was going to do some analysis just to see how good it actually was. So ADP 500 just means Admorial predictor, and it's only the first 500 Admorials because that's all I did. And the other line is the actual Admorials. And as you can see, the equation finders again, both spot on. I'm like, okay, this is going to be real, real good. So then I did exactly what I told you guys could do with the Admorials and that equation is, and I think I might have misspoke a little bit, but it's basically Admorial 2 minus Admorial 1 gives you prime 3. It's always spaced out like that in a line, but it has to be that way because you need 2 primes for 1 Admorial. So in that way, you could see how Admorial 2 minus 1 versus the primes would look, and that's what that graph is. And it's pretty close when you look at it in that context again. It looks like a pretty good estimate, but then I started doing the differences. And this is like, to me, the true root of prime theory. Everybody likes to do ratios because they always go to 1, yeah, at infinity. But to know if you're on the right track, you got to do differences, and that's magnitude. And in this case, when you do ADP minus the actual Admorial, again, ADP is the predictor, and this is just over the first 500. Yeah, the equation holds and it does zero out a couple times, but then you can see at the end, it's definitely going to go to infinity. And then the primes do look like they might model better, but it's just because they're noisier. They go up and down more, but you can see at the end they are also going to infinity. And if you extrapolate this, this is only the first 500 because I always have limited resources, but no matter how high you get, it'll model pretty good up to the end, and then it'll probably trail off in one direction or another, which means it's not very good for a predictor, especially when matched against some of the other equations that I've showed you, which I'll show you right now again, so you can see the difference between like short range stuff and long range stuff. Okay, real quick before we move on. Prime theory in general, or at least my work, is broken down into between two basic categories: finding primes, actual primes, and predicting primes with some sort of algebraic trigonomic equation and everything. And even the predicting primes can be broken down into two different ways. If you know the previous prime and what nth prime that it is, it's very easy to estimate the next prime. And this is janky, but I didn't feel like writing these down and screenshotting them. But that's the relationship right there. P2 over P1 is roughly equal to N2 over N1 because they're both asymptotic to 1. And then if you do the algebra, at the bottom you get P2 is approximately equal to P1 plus P1 over N1. So in layman's terms, the next prime is equal to the previous prime or the current prime plus the average spacing of all the primes up to then. It's really logical. The other way you can do it is P2 over P1 minus the harmonic, the P1 nth harmonic is roughly equal to 1. And if you do the algebra, it comes out the same exact way. It's just the asymptotic nature of both the natural numbers and the prime numbers. And it's nothing new, but I found it both ways. All right, those two screenshots are what in the past I've called growth and decay. The first one, obviously, the numbers all go up to infinity. And in the second one, they all decay down to 1. And as you can see, my two equations, m in a plus b versus the primes themselves. And as you can see, I'm pretty close, but it's starting to trail off. And this is, as you can see by the numbers, this is at the prime number just under 5 million. So the first 341,993 primes. And that is the bottom of my spreadsheet for those graphs. And as you can see, I'm off by, a few thousand, which is almost the M is almost within the square of 5 million, but not quite. So, and what equations are M and A plus B? That's this. Okay, the equation on top, BP and TE, just stands for best prime number theory ever. I was real excited the day I came up with that one. But that's M, that's MEM. The second one, the one at the bottom that's red, that's A plus B. I just split it up in the spreadsheet as A plus B because it's a big equation, and you know that's aleph plus bet. I guess it's maybe symbolic a bit too, but that's the two equations. So you might be asking yourself, well, then what is that middle equation when you change the pi to v? And that is the crux of the argument. There will probably be some day where I put on some smooth jazz and riff about prime number theory like I'm prime number theorist Richard Feynman, but today ain't that day. Let me just say that is the variable that I've been trying to isolate in so many ways, because that variable, because it's a natural log within another natural log, it is very small and it becomes a smaller part of the total equation over time, which is good if you can isolate it, but it's a value that that natural log of that value is really close to natural log of pi, which is why it's pi in my mem equation. But it seems like over infinity, it goes to ln of e, which is 1. So I'm trying to find an algebraic way to make my equation, just that little part of it, go from pi to e, Euler's number, over infinity. And I can't figure out how to do it. Not yet, at least. Lastly, with algebra, I mean, I've come up with a bunch of ideas how to do it in other ways with like calculus and differential equations and stuff, but I'm trying to do this all with algebra. Just for the mathy people, I guess, that made it here, not counting the algebra thing, my best idea would be to craft some sort of custom Borwein integral that goes from pi to e over infinity. Okay, I was going to do something different, but to end this video, instead, I'm just going to go over why maybe the Admorials were not a good way to predict the primes without a whole lot of work, and I can do it better, obviously, in other ways. They are a good way to find the primes, and that's because, to me, in a way, they take out some of the degrees of freedom if you use them properly. And so I'm going to explain it in layman's terms, but this is what I'm going to work on next, I'm pretty sure, to use them to actual find primes as efficiently as possible, or at least more efficiently than I can do it in other ways. And so that is, since you know that each admorial, when you add on another prime, always has to go smoothly to a mod line right next door. It can't jump over mod lines. You also know that the primes that you add to the admorial always have to be on the 1 mod 6 or the 5 mod 6 side. And so that gives you, well, it gives you 12 different combinations for the whole game, but at any specific point, you only have 4 different combinations. Let me explain. Okay, so let's say your current admorial, doesn't matter what the number is on the 3 mod 6 line. So you know it's odd. And you add a prime, the next prime, doesn't really matter what it is. You know that new admorial, the old admorial plus the prime, is going to either be on the 2 mod 6 line or it's going to be on the 4 mod 6 line. You know it's going to be even because the odd admorial and is odd because it's on the 3 mod 6 line and prime numbers are always odd. But you know it's going to be either on the 2 or the 2 mod 6 line or the 4 mod 6 line, the new admorial. And you know the prime number itself has to be from the 1 mod 6 line or the 5 mod 6 line. And so you only have 4 different combinations that you have to check. And it'll probably be self-evident which mod line it's going to be on, which would mean in some way that admorials are predictive of the mod line that the prime is going to be on. And you know the majority of the time it's going to be on the 5 mod 6 line as opposed to the 1 mod 6 line because of the race thing in the graph I showed you guys in the last video. So it's a real confusing thing, but that's where I'm going. I'm going to see just how efficiently I can make a prime finder, you know, because that's the name of the game, trying to find the primes in the most efficient way that I can with this current setup. So that's what I'm going to be working on next. All right, signing off. As always, rule number 1, do not touch each other without another person's consent, aka do not hurt each other. And rule number 2, it's all about honesty. Lies are ticked down, aka try not to lie. All right, I'll talk to you guys later.